Well, welcome people. This is another video to go over some things that we've been studying in algebra class. What we've been talking about is systems of linear equations. So that involves two or more equations being solved at the same time, or sometimes we can have two or more graphs on lines on the same graph. So this is a review for a quiz. I think it's 6.2 quiz. We've already covered section 6.1 and we've covered 6.2, so this will be the quiz over those two sections. So let's go ahead and start with this first section. It says match the following conditions A, B, or C to the given description of the linear system. And so part A is where we have different slopes, and to kind of do a brief review. And if you'll go ahead and do this on your paper or a piece of scratch paper, this should help you out quite a bit as you do this part of the quiz. So what I would do is I would just draw yourself three coordinate planes. Just show the x and y axes. Let's get us three of them going here. And we're going to label this first diagram, we're going to label it A, this one B, and this one C, to go with these different conditions A, B, and C here. So the first one says we have different slopes. So if you have different slopes, it means the two lines are not slanted the same way. So let me go back here. I want to get a straight edge here. So if I have a line that goes this way and another line that goes this way, you can see that if they have two different slopes, they're always going to cross at one point. So that's one case. So if we have different slopes, then we're going to have one solution. Line B, it says identical slopes and y-intercepts. So what this means that you have the slopes and the y-intercepts are exactly the same thing. The only way that that can happen, let's say we have a line, and then we have another line that has the same slope, slanted the same way, and crosses the y-intercept at the same spot. Really what you have is you have identical lines. So you have one line over another, so these are identical lines and they have infinite solutions. The third case is where we have identical slopes and different y-intercepts. So let's say for line A may have a negative slope and it crosses the y-axis here, and then we have another line that has exactly the same slope, but it crosses the y-intercept in a different spot. So this type would give us parallel lines. So with understanding what these three conditions are talking about, A, B, and C, we can go ahead and answer some of these equations or these questions. So make sure that when you do 1 through 10 and then 11 through 13, that you have these diagrams, you match them according to what we've got there, A, B, and C, and then you answer the questions. Let's go ahead and do a couple of these. So parallel lines would definitely be C. I'm going to take that off for the straight edge, so that would be C. Let's go down here, look at lines that have different slopes but the same y-intercept. Well, different slopes but the same y-intercept, that would also be C, wouldn't it? How about a linear system with one solution? Number 9. Well, one solution we can see from our picture. That would be A. So again, in doing questions 1 through 10 and also 11 through 13, make sure that you draw a diagram that fits the conditions of A, draw yourself a diagram that fits the conditions of B, and also for C. And then once you draw your three diagrams, go back through and see the descriptions that are given through each problem and match them. Okay, let's move on now. Let's go on to number 11, 12, and 13. Now on these problems, all that you're asked to do is just to rewrite the equation in slope-intercept form, and then write if the lines are identical, parallel, or intersecting. So that goes along with what was taking place 1 through 10. And then once you identify them as identical, parallel, or intersecting, you're going to tell me if they have one infinite or no solution. So we're going to go ahead and do number 12 first. And now some of these are a little bit tricky. Let's go ahead and do number 12. We'll subtract 2x from each side, so that'll be a negative 2x. And then we divide everything by 7. So that's the equation that fits this. And now let's go to number 12. or the other part of 12. So if you look here, I've got x's on the same side, or on different sides. There's a 3x, there's a negative 3x. I've got to get the y by itself, so I'm going to have to do some algebra on this before I start putting it all the way in slope-intercept form. So I'm going to add or subtract 3x from each side. That gives me a negative 6x. So now I've got 21y equals a negative 6x plus 60. And then now I'm going to divide everything by 21. So you see here that I'm really not done. I know this is simplified all the way. This looks kind of large numbers, so this should be a good indicator that some numbers over here can simplify. Well, if I know that 3 is a factor of 6, and I know that 3 is a factor of 21, so this can simplify to y equals 3 divides a negative 6 2 times, and then 3 divides 21 7 times, so that's negative 2 divided by 7x, and then 3 divides 60 20 times, and 3 divides 21 7 times. So now if you look at these two equations, let me write this other one below there in red. You see what we've just found out? They have exactly the same slope and exactly the same y-intercept. Now when you come up here and look at the original equations, they don't even look close to being the same. But as we go through and do our algebra, we find out that they're identical lines. So we're going to write that they're identical. And then we'll tell how many solutions that we have. And we know that identical lines have infinite solutions. Okay, so on number 11, you're going to put them in slope-intercept form, compare the slope and the y-intercept, and see which one they fit. And you'll also do the same for problem 13. Okay. Okay, now we're going to move on to problem number 15. This is similar to the last worksheet with sheets that we were doing, where we would solve a system of linear system by substitution. In other words, we'd get each equation in slope-intercept form, and we would set the right-hand sides equal to each other. So we're going to go ahead and do this with number 15. So we're going to take y, we're going to add 2x to each side, divide by 4, and then add the 20, and then we also have to divide that by 4. Now for the other equation, we're going to add 5x to each side. We're going to divide that by 3, and then take a negative 6 and divide it by 3. Now let's go ahead and simplify these two equations. 2 fourths is the same as 1/2 x. 20 divided by 4 is 5. I'm going to write that over 1, and then for the other one I have y equals 5 over 3x, and then negative 6 divided by 3 is a negative 2. I'm going to write that over 1. So now looking at this problem, we can see that our 2 times 3 is 6, so our common denominator is going to be a 6. So I know with the 1/2, I can multiply it by 3 over 3 to give me 6 on the bottom. For the 5 over 1, I have a 1 on the bottom, so I need to multiply that by 6 over 6 to give me a 1 on the bottom. And then 5 over 3, 3 needs to be multiplied by 2 to get a 6 on the bottom. There's my x's there. And then a negative 2 over 1 has to be multiplied by 6, because 6 times that 1 gives me a 6 on the bottom. Now if you look here, I can see 3 times 2 is 6, 6 times 1 is 6, 3 times 2 is 6, and 1 times 6 is 6. So all these will be 6's on the bottom, so now I can drop my denominators. So 3 times 1, that'll give me a 3x. 6 times 5 will give me a positive 30. And then 5 times 2 will give me 10x. And then negative 2 times 6 will give me a negative 12. So there's the equation I need to solve. Now all this work right here on the quiz tomorrow, if you guys just want to do that on scratch paper, I don't need to see. So don't show me this. I'm going to take your word that you know how to do that. But I do want to see from here on. I want to see these solving steps. Okay, so if you can't do this correctly, you're not going to get this equation, and this is part of it that I'm going to grade. So we're going to finish solving this. I'm going to subtract 3x from here so I can keep my x positive. So that's 7x. And then I'm going to add 12 to each side. You know, that goes to 0, that goes to 42, and that goes to 0. So now I have 42 equals 7x. Now if I divide 7 to each side, I get x equals 6. So that's what the x is worth. Now to find the x, I'm going to take x equals 6, and I'm going to put it in for that x. And it doesn't matter which equation I use. So I'm going to take a -2 times 6, which is the value for x, plus 4y equals 20. So that's a -12 equals 4y plus 4y. Excuse me there. Fix that. It's not equals. Equals 20. We're going to add 12x to each side, or 12 to each side. That will be gone. So now I'll have 4y equals 32. Divide each side by 4, so y equals 8. So that is our ordered pair for the solutions 6 and 8. So if I were to graph these two equations that I have here, they would cross at 6 and 8. Now if you want to check your problem, this is how you check it. I'm going to come over here and do it. You can do this on scratch paper just to check it. So -2 times x, so that's a -2 times 6 plus 4 times y. Y is 8. That has to equal 20. So I have a -12 plus 32. Well, that equals a -20, or equals a positive 20. Sorry. 32 minus 12, that is 20. And 20 equals 20. So that tells me that I've got the right solution right there. So we've done that problem right. So 14 and 16 are done the same way as 15. And on the quiz, you're going to have only 2 of these. You won't have 3 of these to solve. Okay, so much for that. Let's move on to problems 17 and 18.